There is a way to use matrices to solve systems of equations called Cramer's rule. And the way it works is, at least for a 2x2 system of equations, here we have our system of equations, and I'll do the proof of this afterwards. I'm going to just show you how this works first. We're going to make three determinants. One I'm just going to call D is the determinant of the coefficient matrix, which is 3 minus a negative 12, which is 15. We also calculate a determinant which I'm going to call D subscript x. This is the determinant of basically the coefficient matrix if you were to replace for x, if you were to replace the x column with the two numbers after the equal sign. So you replace the 3, 6 with the 4, 13. When we do that determinant, it becomes 4 plus 26, which is 30. And then D with a little y there, that's the determinant of the coefficient matrix after you replace the y column with the two things after the equal sign. So I still have the 3, 6 here, but now I have 4, 13 there. And that becomes 39 minus 24, which is 15. Well, what do I do with all these? Well, the answers are going to be x is dx over d, which is 30 over 15, which is 2. And the y is going to be dy over d, which is 15 over 15 is equal to 1. And that's the answer to the question, 2 and 1. Now the nice thing about Cramer's rule is that it also works for a 3x3 system of equations. Here we're going to need 4 determinants. The first one I'll just call D, and that's the determinant of the 3x3 coefficient matrix. That's 1 minus 2 minus 3. And if you work that out, it ends up becoming 7. 3 more. D with little x is the determinant of the coefficient matrix, but instead of the x column, we replace it with the 2, 15, negative 12. And whatever method you use to work that one out, you end up with 7 again as your answer. dy is the coefficient matrix, but instead of the y column, we replace it with the 2, 15, minus 12. And when you do the dy, when you do this one, you get 14. And finally, dz is the coefficient matrix, same as this thing, but instead of the z column, we put these 3 numbers. Now, why this works, I'll show proof afterwards. But for now, this is the process. And dz becomes 21. So then our answers are just x is dx over d, which is 7 over 7 equals 1. And y is this dy over d, which is 14 over 7, which is 2. And z is dz over d, which is 21 over 7, which equals 3. And that's how you do Cramer's rule. There is a proof of Cramer's rule that I'm going to show. Now there is a surprisingly short proof of this. So imagine I have I'm going to show for a real generic 3x3 system of equations. So here is a system of 3x3 equations. I'll just put these little a subscript 1, k subscript 2, and so on. And let's see what happens with this thing. First of all, D would just be A1, A2, A3, B1, B2, B3, C1, C2, C3. Let's kind of hold that off on the side. D with little x there, well, that would be this row, the column, sorry, with the x's. The first column would get replaced with the numbers after the equal sign. I'm going to, now, because D1 is equal to this big expression, I'm actually going to write in that big expression instead of D1. So it's going to get kind of ugly for a second. A1x plus B1y plus C1z. And then the second and third column don't change. So this is still a 3 by 3 matrix, but these D's are getting replaced with these more complicated expressions. It's getting pretty ugly. But now, I'm going to do something kind of slick. If I were to multiply the second column by negative y, negative y times column 2 plus column 1, it would cause these three things here to cancel out. And if I do negative z times column 3 plus column 1, that would cause these to disappear. But when you do column operation number 3, the determinant doesn't change. So whatever the determinant was, it's still going to be that when I just get rid of all this stuff. So I get A1x, A2x, A3x, B1, B2, B3. Those don't have any y's attached to them or anything. They never did. Now I'm going to do a reverse thing here. You see, this is if I multiply column 1 by x, the determinant gets multiplied by x. So I'm going to sort of factor it out. And then I have A1, A2, A3. The determinant, if I remove this x from it, the determinant gets reduced by a factor of 1 over x. So I put the x back in there. B1, B2, B3. It's a little hard to think about. But basically it's the opposite of the rule that when you multiply everything in a column, if you multiply a column by a constant, the determinant gets multiplied by that constant. Well, this thing here is just the same thing as d, so it's x times d. So I summarize, dx is equal to x times d. In other words, x is dx over d. And by the same sort of argument, I could work out that, which is Cramer's rule. So that's a pretty slick proof of that. Mainly for a test, you'll want to know how to use it, which is the first 4.5 minutes of this, and the last half was the proof, in case you're interested in that.